Hi, everybody. It's a pleasure being here. Does everybody who is physically in the room have a handout? And does everybody on chat have a handout? Let me have a look. Okay. Awesome. So I have no business being in this conference. I'm a philosopher of mind. I work on perception. And the title of the talk is Weber's Law, which is this thing in psychology and its connection to inheritance, which is a thesis in the philosophy of mind, particular thesis about what phenomenal character is. Why am I here? Well, this talk touches on the themes of this conference because it is, well, trivially about the metaphysics of phenomenal character. It also touches on the concept, on the metaphysics of length properties, and it touches on the metaphysics of property dissimilarity. So these are similarity and dissimilarity relations between properties, not particulars. So all these things are nice metaphysical topics that we'll come across. And it also touches upon the epistemology of metaphysics in the sense that we're going to use an empirical law, Weber's law, to figure out something about the metaphysics of phenomenal character. And the work I'm going to present is joint work I've done with Assaf Weksler at the Technion. And our target for today is this fancy thesis called inheritance, or sometimes you can think of it as extreme externalism. And what this thesis, very popular thesis, says is that the phenomenal character of an experience, what it is like for the subject to have the experience, well, that's determined by the complex of sensibles that you experience, i.e. in having that particular experience. Let's unload some terms. So by determined by, I mean some metaphysical necessitation relations, like identity or grounding or supervenience, all of those would do. By sensibles, I mean sensible properties, so things like colors or shapes or length, things that you can perceive. Their instances and the physical objects that have them, the individuals that instantiate those properties. Hence, so all the sensibles are supposed to be stuff outside your head. Hence, the other name of inheritance is extreme externalism. Final clarification: when I say the sensibles experienced, I'm agnostic here about what experienced. What's the experiencing relation here is. If you're a representationalist, experiencing could just be representing, sensorially representing. If you're a Russellian relationalist, or a relationalist and a realist, then experiencing can be being acquainted with, right? Those are two versions of the inheritance thesis. I'm going to attack all of them, right? I'm going to attack inheritance thesis in its full generality. Before I attack it, I want to tell you why it's so popular, why it's so cool. There are basically three broad motivations for inheritance. The first is just the observation that when somebody asks you what's it like for you to see a green ball, say, then you will tend to mention properties like greenness and sphericality in your answer, right? So what's it like to have an experience is something that's describable in terms of sensibles, and commonly thought only sensibles, only external stuff. So that's the first motivation for the thesis. The second motivation for the thesis is a type of naturalism. So if you're the type of person who thinks that the experiencing relation is naturalizable, so either you think that acquaintance is a natural relation, or if you think that sensorially representing is a naturalizable relation, that's a very common view. Then, if you adopt inheritance, then you have a naturalized story about phenomenal character that is kind of very appealing to the physicalists in the crowd. And the final motivation for inheritance is has to do with semantic and epistemic considerations. The idea is, well, if all that if the nature of phenomenal character is ultimately to be explained in terms of bearing a relation to sensibles, to stuff outside your head, then because phenomenal character is like a paradigm of epistemic evidence, a type of paradigm semantic relationship enabler, then there are not going to be any deep unsolvable mysteries about how experience helps us come to have knowledge about the external world, or about how it enables us to refer to things that we haven't been able to refer to before we had the experience. Okay, so those are all common motivations given for inheritance. Nevertheless, I'm going to go after it today. And there are two strategies that are commonly used to go after inheritance. The standard strategy, which I won't be using today, is to just try to produce two possible experiences such that they are of the exact same complex of sensibles. So in both experiences, you are experiencing the exact same complex of sensibles. Nevertheless, they differ in phenomenal character. So one example of this strategy is Peacock's trees, right? You see two trees. One of them is further away from you than the other. Argument Peacock makes, in experiencing both trees, that you have two experiences that differ in phenomenal character, right? One of the trees looks smaller than the other in some sense. Nevertheless, you experience the exact same properties in both experiences, exact same particulars. You can think of both trees being the same tree, right? You just move between the time you have the first experience and the second. And that kind of direct strategy, as people in the literature who are kind of au fait with the literature know, leads to long and arduous debates about whether or not you do actually experience the same complex of sensibles in the two cases, and these debates drag on, typically without clear resolution. So today, I'm going to try an indirect strategy. So I'm going to derive a consequence of inheritance once it's coupled with two theses that I won't be arguing for. I'll take them for granted. I'll return to this issue of taking them for granted in the end, assuming I have time. Then I'll try to undermine that consequence with appeals to Weber's law, and then I'll conclude. Okay, so here's my indirect strategy. I'm going after a principle called the dissimilarity principle, and to understand the dissimilarity principles, we have to combine inheritance with two theses. The first thesis says that phenomenal characters stand in gradable dissimilarity relations to each other. So, to give you an example, an experience of a length of 4.5 centimeters is phenomenally less dissimilar from an experience of a length of 5 centimeters than an experience of 4.5 centimeters is from an experience of a length of 15 centimeters, right? So you have these two pairs of experiences. There's a dissimilarity relation between each pair, and you can grade it. You can say that the first pair are phenomenally more similar or less dissimilar than the other pair. That's what the first premise says. Second assumption, it's about the size of these gradable dissimilarities. It says the size of gradable phenomenal dissimilarities is determined by the size of the internal dissimilarities. I'll explain what that means in a second. The internal dissimilarities between the things that determine those relevant phenomenal characters. So there are these phenomenal characters. They stand in dissimilarity relations between them. What determines the sizes of these dissimilarities? Oh, it's whatever determines. It's the size of the similarities between whatever determines the phenomenal characters themselves. Well, except that I promised to say what internal dissimilarities are. By an internal dissimilarity, I mean a dissimilarity that's determined by the natures of the dissimilars, as opposed to a dissimilarity that is merely projected by us onto the dissimilars. So let me give you an example to make all this more concrete. Here's the example. The phenomenal dissimilarity between experiences of 4.5 and 5 centimeter lengths just can't, if you accept this premise, just can't be bigger or smaller than the phenomenal dissimilarity between experiences of 14.5 centimeters and 15 centimeter lengths if the internal dissimilarities between the things that determine the phenomenal characters of all these experiences, in particular the experience of 4.5 and 5 centimeter length, is itself identical to the size of the similarity between the things that determine the phenomenal characters of the experience of 14.5 centimeters and 15 centimeters. Now, all this talk about the thing that determines the phenomenal character, that's very simple. If you accept the inheritance thesis, those are just going to be the dissimilars, right? So, if you accept inheritance and you accept these two theses, what falls out is this dissimilarity principle, which is going to be my chief target. The dissimilarity principle says the size of phenomenal dissimilarities is determined by the size of the internal dissimilarities between the complexes of sensibles experienced. For example, if the length of 4.5 centimeters and the length of 5 centimeters are just as dissimilar from each other as the length of 14.5 centimeters and the length of 15 centimeters are dissimilar from each other, then the experiences, one experience of 4.5 centimeters and the other of 5 centimeters, that pair, and the experience of 14.5 centimeters and 15 centimeters, that other pair, those two phenomenal dissimilarities are going to be the same size as well. Yeah? That's what the dissimilarity principle says. I'm going to argue that it's false. I'll skip over a clarification. If it comes up in Q&A, I'll get to it there. Let's talk about Weber's law. Weber's law is an extremely well-confirmed law in psychophysics. Here's a simplified version of it. It says, across a wide range of stimulus intensities, call them intensity 1 and intensity 2, where the intensity 2 is larger. It's a larger intensity than intensity 1. It becomes harder to discriminate those two intensities, which means it becomes harder to correctly tell that the larger intensity is in fact a larger intensity, as the ratio of the two intensities decreases, so it comes closer to 1. So this is about ratios as opposed to differences. So for example, if I show you a 4.5 centimeter length, and then I show you a 5 centimeter length, and I ask you to choose the longer one, your probability of success is going to be identical to your probability of success. That's what harder means. It's going to be identical to your probability of success as if I showed you a 45 centimeter line and a 50 centimeter line, right? And furthermore, if I show you a 4.5 centimeter length and a 5 centimeter length, it's going to be easier for you to tell that the 5 centimeter length is bigger, to discriminate them, than it's going to be if I show you a 14.5 centimeter length and a 15 centimeter length. Because the ratio of 14.5 to 15 is closer to 1 than the ratio between 4.5 and 5. Right? So that's just what Weber law says. When people first hear of it, they're super surprised. It's true. Go out and check it out. Cool experiments. All right. So I'm going to leverage this empirical fact to argue against the dissimilarity principle. The argument is on your handouts. I'm going to go through it fairly slowly. Part 1 of the argument is on claims 1 through 3. So by the dissimilarity principle, if the size of the dissimilarity between 4.5 and 5 centimeters were identical to the size of the dissimilarity between 14.5 and 15 centimeters, then experiences of 4.5 and 5 centimeter lengths would be phenomenally just as dissimilar from each other as experiences of 14.5 and 15 centimeter lengths. All right, that's just an application of the principle. Here's a controversial premise. It's called same dissimilarities. Hey, the size of the dissimilarities between 4.5 and 5 centimeter length is in fact identical to the size of the dissimilarities between 14.5 and 15 centimeters. Conclusion, that's claim 3, by the dissimilarity principle, experiences of 4.5 and 5 centimeter lengths are phenomenally just as dissimilar from each other as experiences of 14.5 and 15 centimeter lengths. That's part one. Part two. Weber's law tells us that it's harder to discriminate 14.5 and 15 centimeters than it is to discriminate 4.5 and 5 centimeters. That's just the empirical fact that I told you about. Now here's a controversial premise. It's called the discriminability phenomenology link. It says the harder it is to discriminate between two stimulus intensities, the smaller is the phenomenal dissimilarity between experiences of those intensities. Therefore, claim 6, experiences of 14.5 and 15 centimeter lengths are phenomenally less dissimilar from each other, or more similar to each other, than experiences of 4.5 and 5 centimeter lengths. Now, part one gave us a conclusion, assuming the dissimilarity principle. Part two told us that conclusion is false. So, claim 7, since those are inconsistent, let the dissimilarity principle go. The dissimilarity principle is false. That's the shape of the argument. The shape is nice, but I have to fill in the kind of work by arguing for same dissimilarities and for this for the discriminability phenomenology link. One clarification about the discriminability phenomenology link. I don't mean it as an exceptionalist generalization. It's a ceteris paribus claim, right? So of course, if the subject has some cognitive malfunction or unconscious inference or phenomenal overflow, any other abnormality, abnormally conservative response biases, then all those things can make the discriminability phenomenology link fail. But of course, these special ceteris paribus conditions needn't always obtain, assume that they don't. Okay, so I'm going to take defending the two key premises, the similarity principle and the discriminability, the same dissimilarities premise and the discriminability phenomenology link. I'm going to defend them in reverse order. So I'm going to start with the discriminability phenomenology link. And my argument here, you could think of it as an argument from lived experience. It goes like this. So consider a pair of lines with discriminable lengths. For example, a 1 centimeter or 2 centimeter line. Maybe on your handouts you have 4.5 and 5 centimeter lines. The particulars don't really matter. So they have discriminable length, and the phenomenal characters are different too, right? They're phenomenally dissimilar from each other to some extent. Now, because Weber's law holds, we know that to make the lines harder to discriminate, we must bring the ratios of the lengths closer to 1. And no matter how you want to bring their length closer to 1, you can always do it by just 3 transformations. 1, shorter the longer line. 2, lengthen the shorter line. Or 3, add the same length to both lines. Those are a combination of these 3 transformations will always allow you to get the lines closer together in ratio, no matter what the ultimate ratio is or how you got to that ratio. And what I'm going to say is, hey, when you look at each of these 3 transformations, you're going to get a preservation of the discriminability phenomenology link, so you get it in general. So you get the discriminability phenomenology link holding in general. The argument is this. So let's start with transformation A. So that's shortening the longer line. So suppose we use that transformation and consider what's going on as the longer line gets shorter and becomes closer to the shorter line in length. Now, if the discriminability phenomenology link holds, as I want it, then as this process is going on, the experiences are going to be phenomenally more and more similar, and that is indeed what you will find if you try this out for yourself. If the phenomenology discriminability link doesn't hold, then you're guaranteed that at one point at least during this process, as the longer line is shortening, you're going to get one experience after the other, such that the later experience is not phenomenally more similar or equally phenomenally dissimilar from the previous one, right? And of course, that is totally out of line with lived experience. That's just not what happens. So transformation A is in line with the discriminability phenomenology link. The same story goes for transformation B, where you lengthen the shorter line, right? So if the link holds, and as you lengthen the shorter line, the phenomenology is going to go more and more similar, and indeed that's what you find. If the discriminability phenomenology link is false, then at one point during this process of lengthening the shorter line, you're going to come up with a pair of experience such that the latter one is phenomenally more dissimilar or equally as dissimilar as some of the previous ones. And again, this is totally out of step with lived experience. This never happens. And the argument for the third transformation is totally symmetrical, right? So you're adding the same length to both lines. As you're doing that, you're going to find, counterintuitively, but you should do it, it's really cool. You're going to find that the experiences are becoming more and more and more similar to each other, less and less dissimilar to each other. And that is just what you would expect if the discriminability phenomenology link held. If it doesn't hold, then it's going to break at some point. So suppose, for example, that you're starting with a 1 centimeter line and 2 centimeter lines, and then you jump to a 41 centimeter line and 42 centimeter line, and then there's a 101 centimeter line and a 102 centimeter line. Throughout these processes, the experiences are getting much more similar, just like you would expect. When they get to 101 to 102 centimeter line lengths, you're basically at total chances being able to tell which is longer. And indeed, the experiences are similar. If the discriminability phenomenology link doesn't hold, that shouldn't happen, right? Okay. So since each of the transformations confirms to the discriminability phenomenology link, the link holds generally. There's also a dialectical point in favor of the discriminability phenomenology link. So the argument I just gave you fits really nicely with two natural thoughts. So the first natural thought is that the psychological function of phenomenal dissimilarities, what phenomenal dissimilarities helps us do. The psychological function of phenomenal dissimilarities is to serve as input for our discrimination capacities. It's how we make discriminations. That's a natural thought that aligns really nicely with the link. Here's another natural thought that matches really nicely with the link. We can study phenomenal dissimilarities precisely by studying discriminations. That's why the field is called psychophysics. But consider in contrast the position of those denying the discriminability phenomenology link. Those who deny this link are suggesting that even in completely normal and unproblematic cases where none of the ceteris paribus clauses is triggered, discrimination and phenomenal dissimilarity can be out of step with each other. But if so, then there are these two really big questions that arise. So what is the psychological function of phenomenal dissimilarity? And furthermore, which tasks other than discrimination tasks can the psychologist use to empirically study phenomenal dissimilarities? Okay. Now, without well-motivated answers to these questions, it seems that those who deny the link are risking creating kind of new epistemic puzzles for empirical psychology, and the motivation is kind of unclear. The motivation, to my mind, seems just to preserve the dissimilarity principle, which is what I'm going to argue is a bad motivation. I want to make a note in case there are any psychophysicists in the crowd or in the Zoom room. Everything I've said so far, yes. 5 minutes, okay, cool. Everything I've said about the discriminability phenomenology link does not assume the truth of Fechner's law in psychophysics or the falsity of Stevens' law in psychophysics. It may look like that. If you're worried about that, there's an appendix at the end of your handout that explains why it doesn't. I'm going to skip that for because I only have 5 minutes left. All right.
You can go a few minutes longer. You can
All right.
decide how to be on.
Okay. I still owe you an argument for the same dissimilarities premise. The same dissimilarities premise, I remind you, said that the dissimilarity between the length of 4.5 and 5 centimeters is identical to the dissimilarity between 14.5 and 15 centimeters. Notice, this is a psychology-free claim. It's just about lengths, right? It has nothing to do with psychology any longer. We're doing dissimilarity of length metaphysics now. All right, so there's a question about how you measure dissimilarities in lengths. We obviously adopt the difference measure of length dissimilarities. It says that the size of dissimilarities in length is proportional to the absolute value of their difference, mathematical difference. There's some abusive notation here, which you'll forgive me, right? I'm talking about the measures of the lengths rather than of the lengths themselves. Which measure of length you choose doesn't matter as long as you use one of the standard ones. But you can also have other measures for dissimilarity in length. You can use a ratio measure that says that the size of dissimilarities in length is proportional to the ratio. Or you can use a logarithmic measure of length difference. All of these have been discussed in the literature on this. Logarithmic measure says that the size of dissimilarities in length is proportional to the absolute value of the mathematical difference between the logarithmic functions of those length measures. The basis of the logarithm doesn't matter. Okay, so we accept the difference measure, so what do we have against the other two measures? The shape of the answer is going to be, there are two types of constraints on measures of dissimilarity. There are going to be formal constraints that derive from the nature common to all dissimilarity relations between properties as such. And there are going to be some material constraints that derive from the nature of the particular magnitudes whose intensities are being compared for dissimilarity. Start with the ratio measure. The ratio measure is going to violate some formal constraints. So a formal constraint on dissimilarity is that it's irreflexive. So the dissimilarity between any length and itself is 0, but the ratio measure violates that because the ratio between a length and itself is 1, not 0. A symmetry constraint. Symmetry constraint says the dissimilarity between A and B is going to be identical to the dissimilarity between B and A. Ratio measure violates that, right? Because the ratio between the ratio between A and B is going to be in general dissimilar from the ratio between B and A. Finally, there's an additivity constraint. Whenever Y is an intensity intermediate between intensity X and Z, intensities X and Z, the measure of the similarity between X and Z must be equal to the sum of the measures of the similarities between X and Y and then between Y and Z. That's an additivity measure. This too fails with the ratio measure because in general the ratio between A and B plus the ratio between B and C is not going to be equal to the ratio between A and C. So that takes care of ratio. What about the logarithmic measure of length dissimilarity? We claim that this violates a material constraint. The material constraint begins with two observations. Observation 1. When you place any two lengths so that they're parallel and aligned at their starting points, it is pre-theoretically obvious that you can see and point to their dissimilarity. In fact, the dissimilarity is going to be located precisely where the one ends and the other ends. Here's another pre-theoretically obvious claim. If you can precisely I've already basically said it. You can precisely locate the dissimilarity between two lengths by arranging them so that they start at the same point and then end at different points. The similarity is going to be just between the two ends that extend over each other. Here's a nice metaphysical explanation of this fact. Length dissimilarities are just lengths. They're just more lengths, right? The dissimilarity between length A and length B, in fact, is just the length whose measure is going to be the measure of the length that you find when you put the two lengths aligned at the edges in parallel and look at the space that's left, at the length that is left. And once you accept, if you accept that, then you're going to deny the logarithmic measure. Why? Well, it's just a fact that when you take two lengths and look at the length that separates them, the difference length, it's going to be the same difference than if you took those two lengths and extended them by an equal amount, right? If you accept that length, those lengths that measure the difference are identical to length dissimilarities, then any acceptable measure of length dissimilarities is going to have to respect the fact that when you measure the dissimilarity between length A and B, you're going to have to get the same result as if you measure the dissimilarity between A plus D and B plus D. And that is a fact that the logarithmic measure violates, because in general, the absolute value of the difference between log of x and log of y is going to be distinct from the absolute value of the difference between the log of x plus d and y plus d. All right, I am over time. Let's talk about the upshot in a second. Once you reject the dissimilarity principle, you've accepted that some factor other than sensible complex dissimilarities shapes phenomenal dissimilarities. So phenomenal dissimilarities are going to be determined by some factor other than dissimilarities between the sensibles. But once you accept that phenomenal dissimilarity, this other phenomenal dissimilarity shaping factor, it's going to be real difficult to see how you could deny that that very same factor also shapes the phenomenal characters of the experiences that are dissimilar themselves. But once you've said that inheritance is false. Thank you very much.